Hello, Huggies worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today we're going to take a look at a question from John Lang. Okay, he is trying to build a GoBox for his AnyTone At-D578UVIII Pro, which is a mobile radio. Okay. And it'd be a very nice thing to use for that. Let me show you a similar radio. Okay, this is a similar radio. It's a Yaesu FT7800, which is no longer made, but it is a dual band, 2 meter and 70 centimeter radio. It's a nice little radio. The front comes off, and you can mount the front any place that you might like to. Okay, and I'm just going to put that back on. Okay, so the radio, the other radio, the radio he mentioned, is almost the same size, shape, and weight. Okay, it takes 12 volts. This one has a little fan on the back, a connector for the antenna, and all your controls and stuff up front. Note here that the speaker is in the radio housing, not in the front. So if you remote this somewhere, you either have to plug into here for an external speaker, or put it close enough that you can hear what it is saying. A lot of people with their GoBoxes like to fix these things up so they can use a headset or headphones or something like that. Okay, so we're going to put this in a box. Now, let's get back to his question so we can see. A GoBox is a box, literally, that you can grab and go. Put it in your car and go, like if you are going to support the Emergency Operations Center, or if you just like to go operate on mountaintops or whatever, or from parks on the air. You can put a GoBox together so it has your entire station in one package, including the power, the transceiver, usually a light of some sort, so you can operate it after dark, and your antenna connections. You can't usually put your antenna, although some people will leave a space where they can coil up a dipole and put it in. Other people use different types of antennas, like a tripod mounted ham stick or something like that to do their work. The use of what antenna to use with the GoBox is a long thing. Now I want you to note on the cable, here, this is the part that goes to the radio. This part here is an Anderson power pole connector. You can see it in the overhead here. These are what are so-called genderless connectors. Any two can mate to each other, and they are kind of the best practice among emergency operators to have their power connectors be that way. If you look at power supplies these days, a lot of power supplies have the Anderson power pole connectors built in. That's the standard for 12 volts, not 5, but 12. There's a lot more stuff in ham radio working on 5 these days, so it might be good to include a little cigarette lighter type output, fused of course, into which you can plug one of those things that gives you a USB connector with 5 volts on it that you can use to charge phones and things like that. You want to put that in your GoBox too. So he intends to use two 12 amp hour, and he's getting all wrapped around the axle on definitions in power. Okay, let's take a look at voltage, power, current, etc. Okay, voltage, which is sometimes written E and sometimes written V, okay, is the electromotive force. And think of this as the electronic pressure that we're using to push current through wires. I, which comes from the French word for intensity, has to do with the current. This is the current. And a current is composed of little thingies, electrons, flowing past a given point. And basically it's a mole of current. If you don't know what that means, don't worry about it. But it's 1 coulomb, and I've undoubtedly misspelled that, 1 coulomb of charge. 1 coulomb of charge, 6.24 times 10 to the 23rd, something like that. I don't know, 24th? I'm only off by a factor of 10 or so. 1 coulomb per second past a given point. So it's measured at a point, and you're looking for the current that goes past that point, and that current is measured in amps, whereas in charge right here, you measure that a different way. Okay, so we've got the push, and we've got what is pushed. Okay, the other element to this little elementary thing here is the resistance, R. Resistance, which is R in equations and is ohms. So like you have, say, 25 ohms, that's the resistance. So you've got the force, the current, and the resistance to the flow of the current. Okay, so those are your fundamental items. Now if you want to measure energy, you've got to look at the watt. The watt, so the power equals the voltage times the current. Power in watts equals voltage in volts times the current in amps. Okay, that's the power. Power is not energy. They are not the same thing, okay? The amount of power over time, actually multiplied by time, over a period of time, is energy. Energy is the ability to do work, okay? Okay, so power is work is energy is the ability to do work. To do work. And energy is equal to watts times the time over which that current goes. So watts times time equals the energy. Okay, and I won't get fancy with symbols and stuff, but the watts times the time. If you have kilowatts power, a kilowatt for an hour is a kilowatt hour. Okay, kilowatt hour. And this is what the energy company sells you. It's not kilowatts, that's the power. Kilowatts over a period of time. Kilowatt hours. Okay, which, by the way, here in southwestern Colorado sell for about 18 cents. Okay, so that adds up quite a bit. So that's a 1,000-watt light bulb on for 1 hour will cost you 18 cents. Well, if it's not a 1,000-watt hour, maybe it's a dryer that takes 1,000 watts that's on for an hour. That'll cost you 18 cents. It adds up. He wants to use two 12-volt, 10 amp hour lithium batteries. So he's got one battery here that's 10 amp hour. What does that mean, amp hour? It's 12 volts. It means that if you connect a load to this, an appropriate load, a resistance, current will flow at the rate of 10 amps and after the end of an hour, the battery will be completely discharged. Okay? So the 10 amp hours is the capacity of the battery. If you want to know the energy in the battery, you multiply the 10 amp hours times 12 volts, and you get 120. Remember, volts times amps is watts. 120 watts for an hour, so 120 watt hours. Okay, that would go here for less than 2 cents. Okay, I know it's hard to pedal a bicycle and it takes that much power, but when it comes to like water or steam or something like that, turning a generator can be quite cheap. Okay, so he has two 10 amp hour batteries at 12 volts that he wants to connect in parallel. 10 amp hours. This is the equivalent of one battery with 20 amp hours. Okay, now what is the maximum rate at which you can discharge current from these batteries? Well, that you have to find from the battery specs, but you can easily power a radio like this. There's your 12 volt input. You can easily power a radio like this on transmit, although I'd keep the power down to about 25 watts. You can easily power that with this battery, okay? Now, the question is, here he says he's going to have operating voltage. Well, if these are lithium ion, you're going to have more like 13 volts, okay? Plus or minus 50, and the radio is rated at 13.8 plus or minus 15%, which is down as far as 12 volts, a little bit below, and up close to 15 volts. So this right here will power it just fine. Now, the current requirement minimum is 15 amps. Okay, so his battery takes 15 amps on transmit, and probably more like 1 to 2 amps, it's a computer inside, on receive. Now, you take the draw, 15 amps, multiply it by the time. Okay, let's suppose this is 1 hour you're transmitting, which is not good for your radio. It won't like it that much transmitting. This 20 amp hour battery can produce 15 amps for more than an hour. Okay, but you're not going to be transmitting all that time. You're going to be doing a lot of listening. So let's say it's 2 amp hours, okay? 2 amps on receive times 1 hour is 2 amp hours. A 20 amp hour battery, this will work for 10 hours in theory, okay? 10 hours. So do you see how I get from the current draw to the amount of current extracted in amp hours from the 20 amp hours? Again, if you want to get the actual watts, you'd have to multiply it by the battery voltage, but it's often easiest to deal in amp hours. Okay, so you've got a radio that you can use very easily for emergency purposes doing this, and that would be about the right size for that. Okay, the transmitter's current rating amp, just supply DC power cable is 20 amps, yes. 20 amp fuse is fine. The maximum you draw is 15 amps. Okay, note we're getting our hours and our amps straightened out. The fuse blows on the amount of current being drawn. If 15 amps is the max, you got a 20 amp fuse in there, you're fine. When you draw the maximum on transmit, it won't blow the fuse. If there's something wrong in the radio, it will blow the fuse. Okay, it's the whole point of a fuse. Okay, am I correct in assuming the 12 volt 20 amp hour battery will actually provide 20 amps of current? No, you got apples and oranges mixed up here. Okay, this is a 20 amp hour. It will do 20 amps for an hour. What is the maximum discharge current out of this thing? Well, you already know it's 15 amps. It's less than this. It can draw that for an hour. You're undoubtedly within the specifications of this battery. However, I'd look up the specifications of the battery to see how many amps you can safely draw from that battery. The 15 amps is fine. Okay. So don't mix up current and current times hours, okay? All right. So I hope that gives you the idea of what's going on. Now, let's talk about reality, okay? You can never draw from a battery all of the amp hours it's charging because the voltage gets too low and it can't push it. And on lead acid batteries, if you draw more than half of the amp hours from it, you actually stand a chance of damaging the battery. You can tell on a lead acid battery what the state of charge is by looking at the voltage, but these are lithium batteries. They're different. There is in each battery a little battery management system, BMS. Battery management system built into each battery. And that will actually shut the battery off when it gets below the state of charge that it wants to. It will also shut the battery down when you're charging it, and you need to get the right chargers for these things, and so on. I would not recommend charging these batteries in parallel. I'd recommend separating them and charging them separately. Check your manual for the batteries to see if you can parallel them. Will the battery management system handle paralleling these batteries? Because what happens when you parallel batteries, if one of them has a lower charge than the other, then you tend to put all of the demand on the one battery. So be careful with this. But I have not heard problems paralleling them, but I am not going to say that that's okay because I've never tried it. Okay, never tried it. But in motorhomes and stuff, a lot of them are going to lithium batteries. Our motorhome happens to have the old lead acid style batteries, which are all different. I mean, this type stuff is the same, okay? But a lead acid battery, you can only put out about half of the stored current before you start to damage the battery. And then you have to recharge it. And you say, well, what's the use of the value? So, well, it's always been done that way since the submarine days of World War II, when they used massive banks of lead acid batteries to run their electric submarines underwater. There was no internal combustion engine. Nowadays, they have nuclear power underwater, okay, and run forever. But well, up to 2 years anyway. Submarines, because they run on electric power underneath, a lot of them are made by a company back east called, are you ready for this? Electric Boat. And they don't make little electric boats you can take out on the pond. They make electric boats for the great big pond. Okay, so anyway, enough on that. A lithium battery, you can draw up to about 90% of the stored charge before you need to recharge the battery, although I wouldn't do that. Lithium batteries don't have the memory problem that the old NiCads had. I know there are people who deny that the NiCad batteries had a memory problem, but I'm here to tell you that they did. Okay, anyway, we don't use NiCad anymore. Cadmium is poisonous, and it's a very outdated battery chemistry for what we use now. Everything is based on lithium. Let me just make sure I answered all of your questions. Okay, So the terms that we've talked about today are volts, amps, hours. Okay. So, and power is volts times amps. Energy is volts times amps times the length of time that that current was used at that voltage. Okay. And obviously it can vary as it does here. So if you want to figure out how long it can transmit, you look at the capacity in either amp hours or watt hours and do your figuring either on amps or watts. I like to do it on amps. It's just easier. Okay? So there you have it. If you'd like to help this channel financially, you certainly can do so by going to dcasler.com/support and looking for a way there that works for you, including Patreon. Also, if you would like to participate in the monthly giveaway, go to dcasler.com/giveaway, and that will give you all of the details. You have to enter with a real live, where to go? A real live envelope here. And that's all it costs, because if you win, I pay the postage, everything like that. There's no tax involved. There's no nothing. It's just a freebie. Okay? So, there you have it. And until we next meet, 73.